welcome back to AWS On Air from the San Francisco Summit. I'm Steve Roberts, developer advocate for .NET and PowerShell. I'm joined by my co-host Kyle.
Hey everybody, I'm Kyle Lee. I am a senior developer advocate on the AWS Amplify team. We're here at the SF Summit in California. And
Sunny California?
It's sunny California, yeah.
All right, so in this session we're going to be talking about the announcement this morning about AWS IoT TwinMaker. And to do that, we're joined by Saras from the TwinMaker team. So Saras, would you like to introduce yourself and tell people what you do at AWS?
Hello everyone, I'm Saras Kaul. I'm a principal product manager in AWS IoT. I work on our industrial and enterprise IoT services, and I'm really excited to be here and talk to you about TwinMaker. We launched in general availability today, so very excited.
Yeah, we're very, very happy to have you. So, all right, so TwinMaker, it's related to digital twins. Can you kind of help us? What are digital twins?
Yeah, because I'm a mobile developer. I don't know what that means at all.
It's not the first time I've heard that. But digital twins is a term that's been around for a little bit. What's confusing about it is the spectrum of interpretations of the term itself. We've heard customers describe CAD and design files as digital twins sometimes, which has high fidelity structural information. We've heard customers describe engineering and simulation, physics-based simulations as digital twins as well of a process. There's also cases where IoT dashboards can be called digital twins. So there's a lot of different interpretations for the term. What we've actually done is taken all of that input to sort of crystallize that into the fundamental. And in this case, we define the digital twins as a living digital representation of a physical object or a process that's dynamically updated with data, so it mimics the structure and the state and the behavior of the physical counterpart. And they're built to drive business outcomes. And we can get into some use cases, but those business outcomes can be almost as varied as the definitions out there. So it's a very broadly applicable technology and a broadly applicable term as well.
Got it. So tell me a little bit about like these digital twins. So you said that they're kind of a representation of a physical object, right? So how then do you essentially take something that would be physical, right, and then turn it into this digital object?
Yeah, great question. It all starts with data. So there is so much data being generated in the physical world. So if you're talking about industrial facilities like factories, we could be talking about entire buildings, or we could be talking about the entire scope of operations, as well as down to a single piece of equipment. So if you think about it, there is a lot of data being generated which forms the foundation of a digital twin. So data in terms of IoT data that's being generated via sensors or in the equipment. They could be cameras that are, taking pictures and recording videos. There's a ton of data in applications that have, documents, user manuals, maintenance history, work order scheduling. So there's a lot of different types of data that forms the basis of a digital twin. But to create a digital twin, you have to bring them all together into some sort of a common context that represents the physical environment. So it isn't just about IoT data by standing on its own. It's about bringing together and fusing together data from these different sources, these different data types, to create a fully comprehensive model of the physical process or the object known as the digital twin.
Right.
Got it. I think a lot of developers can really associate with the amount of pain that must go into trying to convert different data types into a reusable data type across all of these different use cases that might be needed. So tell us a little bit more about like how IoT TwinMaker does something like that. Like how does it take data from a sensor versus the measurements from a building and maybe like the images of a asset that's inside the building or something like that?
Yeah, so there's so many different types of data sources as well as data types that have to come together. So in TwinMaker, there are 4 key pieces that enable developers to build these kinds of digital twins. And it starts with the data connectors. So in data connectors, the service provides this connector framework that allows your digital twins to query and access data in the underlying data source. So the data does not have to move into a single repository. The data does not have to get re-ingested. The data can live where it lives, but through this connector framework, the service can query the data on demand when needed. We've added connectors for services such as AWS IoT Sitewise, that collects data from factories and equipment at the edge and uploads it into the cloud. And this time series data is then stored in AWS IoT Sitewise. It can be stored in S3 as well, and you can access that data through TwinMaker via connectors. Similarly, when we talk about cameras, there's videos being ingested and stored in Amazon Kinesis video streams. It's a purpose-built service for video data. So you can bring the video data in, and through the connectors, again, a built-in connector for Kinesis video streams, TwinMaker can access that data on demand. And it doesn't just end with the services that we have built-in connectors for. We built it in a way that allows developers to build connectors themselves for data stores that they want to connect to. So it's a very flexible connector framework that can talk to data stores where customers are already storing data.
So you're saying that it not only does it have multiple connectors that it works with, but it could take in new connectors that are developed by the developer. So I can make one that is connected to me, and I can have a digital twin. I'm just saying.
We'll get on that right away.
Yeah, this is the bit that I find the most interesting. Like I mentioned in the keynote recap, right? It's I'm used to IoT from the point of view of little devices, but the idea that you can have a twin or an IoT representation of an entire building or a factory or a space that you mentioned, I was like, what? It's
I
cool.
kind of want to do this to my house.
Yeah, it's got me thinking.
The key part that brings it all together is a knowledge graph that we have in the service. This knowledge graph essentially understands all the elements in that physical space that are part of this digital twin and all of the relationships between them, as well as where data for each of those elements reside. So as you build out the entities into a graph and then connect the data connectors into that, we call them components, but you connect that into the graph, it essentially creates this model that gives you a common context and common metadata across all of these disparate silo data sources.
Got it.
And then that knowledge graph then becomes the foundation of different kinds of digital twin applications that customers want to do. So what we hear over and over again is customers want to build a source of truth. This is a source of truth of data, and this is the source of truth of the operation itself. And then they want to take that and do different kinds of applications to it. So a real-time monitoring application, a 3D immersive walkthrough application, it can be analytics application, all being serviced from that knowledge graph or the foundation that drives the digital twin.
Got it. So tell me, because it sounds very interesting, and I'm still trying to understand some of these use cases, right? So I understand that, now I understand that making a digital twin means that I can have this digital representation of some type of physical space or structure, right? So essentially, I could do that with any physical structure, and because I have a background in real estate, theoretically what I could do is I could take something like this and make a digital model of a house that maybe I'm selling or something like that, right?
Yeah, absolutely. So the third pillar, I talked about the data connectors, I talked about the knowledge graph. So the third pillar is visualization. And we've embraced 3D immersive visualization for your digital twins. And so if you're wanting to create a digital twin of a house, you can do a very simple scan to create a 3D model or a reality capture model of your house. Okay. And if you have IoT devices that are sending signals to the cloud, you can connect that to the 3D model in context of where it is getting generated, and that becomes your digital twin.
Wow.
We see this with customers like Carrier, who are trying to build digital twins of building systems, and we see that all of this data, IoT data, can then be represented in situ in 3D models. And these 3D models can be reality capture or point clouds, as I mentioned, but it can also be using existing CAD or building information models, so more traditional 3D assets, and those can be utilized for your visualization as well. So the theme that you'll find in this service is that it's really flexible to enable developers to take it in the direction that they need to. So you'll see that with the flexibility in the data connectors, the model of the knowledge graph, also very flexible. Same thing with visualization. We wanted to enable customers to leverage things that they have already invested in, be it CAD files, BIM files, reality capture, be it existing data stores, or even asset management systems that have equipment and equipment hierarchy. Like, we want to embrace reuse as much as possible, so there is a starting point, like an easy starting point for developers to get started, so they're not starting from scratch.
Oh, okay. So, yeah, because this does sound like pretty complex stuff.
Yeah, I was
that's
going to say,
on.
how do we get started?
Yeah.
Right? How did you make it easy?
So yeah, the service itself is a developer platform. It allows you to create and run your digital twins. How it works is I can show you.
I'm a visual person, so
Okay.
that sounds amazing.
All right. I have a video, and I can talk you through that.
Yay, my favorite
All right.
part of it.
demo.
Anything is just seeing this thing in action.
All right.
All right. So what we have here is a digital twin of a fully built-out cookie factory.
Okay.
Oh, so that's
And-
not your house.
This is not my
okay,
house.
okay.
But my house has cookies.
So,
And what you see here is it's been used as part of a monitoring application or a monitoring dashboard application.
so this is the dashboard and the monitors in the upper right, yeah?
Exactly. So
Okay.
you see top left corner has all the alarms that an operator
Okay.
needs to be looking at. On the right side, top right, you see data from IoT sensors, so your sensors that are measuring flow rate, measuring temperature, RPM, those kinds of data represented in the right format, in the visual format that makes sense for that kind of data. Bottom left, you see the 3D scene. This is the visual representation of the environment. And then on bottom right, you see a video feed. These are coming from cameras that are placed within the environment.
I think if I was the operator looking at this, I'd be constantly hungry watching the cookies coming off the
Yeah,
line.
I was about to say, like, watching cookies sounds like a distraction.
So you see, you have full control and 6 degrees of freedom in the 3D scene itself. You can use the 3D scene to navigate this application, but you also have the flexibility to use the hierarchy. So the hierarchy be, all the equipment that is in the space. You can also organize that by space, but you can use the left-hand side panel to navigate the scene, or the 3D itself. And what that does is, and you'll see that you're trying to figure out what's going on with this one particular mixer number 5. And what that does is, when you click on that piece of equipment, the dashboard automatically updates with data that is coming from that particular piece of equipment. So you see the flow rate and the mixer temperature and the RPM has now changed to reflect exactly the equipment that the operator or the consumer of the digital twin is interested in.
Got it. So this is essentially taking the ability to make a digital twin of the inside of a factory or warehouse or something like that.
Yep.
Get an idea of what is actually going on. There's supposed to be a specific RPM that this specific tool is supposed to be turning at,
Yep.
and one of my sensors can detect that, relay that information back to the system, and then actually show it up in the dashboard.
Exactly. And you'll
Awesome.
see there is live video from the environment. You can be playing that as well, and it's able to pull that up from the understanding of which camera is looking at this piece of equipment. So it isn't just a random video feed. It is pertinent to what the operator needs to
is
be
clicked
looking
on.
at.
Okay.
So this is all giving the operator full context of their operation, and it's giving them the information that they're interested in. So it's not information overload, but it is still giving them the full context.
Okay.
Got it.
If I keep going, we think that the alarms are something that really showcase the power of a digital twin application in this case. So you can have a list of alarms and you can see which ones are in active state. So a specialist that needs to go address these alarms can then look at what are all the alarms that are active in this space, click on them to get the relevant data. The data is coming in from the physical environment. It can be near real time, but there is historical access. So you can go back in time and review the data. So for example, if they were trying to diagnose an issue that caused an alarm, you can click on the alarm, you can see the data that for it in real time, but you can go back in time and see what happened when the alarm was triggered. You can also, because of a common time scale, not just rewind your IoT data, but you can get the video feed from that time.
Oh.
So you can see somebody knocked it over or something.
All
like
data
that.
is data, and you can go back in time and see
It's
that data.
on a common time scale, so it's kind of like going back in time.
Awesome.
And it rewinds the entire system.
Okay. What else do we have?
I have some more video on the setting up of it, but I wanted
Excuse
to.
me. I do apologize. Excuse me. Sorry.
It's okay, Steve.
You're okay.
We're all excited about the
I
video
am
and
so
making
excited.
digital twins as well. Don't worry about it.
Got me. I'm sorry, I've thrown you completely off track there, didn't
no,
I?
that's totally fine.
So what does this look like in the console?
I'll play this. So this is the console. Component types are essentially the data connectors that I talked about. It allows you to create connectors into alarm systems, into telemetry systems, time series databases, wherever you store documents, S3 URLs, so on and so forth. And as I mentioned, there are some that are predefined, comes with the service, but you can also user define your own. You see here, this is the entities being created. So this creates the knowledge graph. It has all of the equipment, all of the spaces, and then the data connectors are associated with the entities to build that knowledge graph out.
Got it.
You go into the resource library. That's where you store your 3D assets. So it can be, your CAD files, what have you, and then use those 3D assets to build out scenes. The scenes are essentially a visual representation of the physical environment. And what's really cool about the scene composer here is once you build the scene out, you can add augmented 2D widgets on top of it that represent the data in situ of the scene. So, you can have alarms that are driven by simple rules. If temperature exceeds, 50 degrees, turn the tag blue, turn the tag red to denote something's wrong. Same thing, like we have a series of 2D widgets that you can use to connect the knowledge graph to your 3D scene so you get that full context.
Got it.
This is great.
So this is really amazing stuff. I definitely want to check this out on my own house. Like I said, I'm definitely going to start hooking it up. So, Sarah, tell us a little bit about where people should go to learn a little bit more about this, and where they should go to just get started, essentially.
Absolutely. So the website is right there, but it is aws.amazon.com/IoT-TwinMaker. And if folks want to use this cookie factory and build their own cookie factory, we have a GitHub repo that has a ton of great samples. The entire functioning cookie factory is in there, so you can go build your own. You can extend that to build whatever else you want out of it. But it also has a lot of good samples for connectors that have data connectors that have been built, and libraries for analytics applications running machine learning on your digital twins, and so on and so forth.
Got it.
We can share the link with the audience here.
Yeah, we'll have the link in the chat, so make sure you check it out. It will be in the chat. Thank you, Sarah, for joining us here on
Thank you for having me.
AWS on Air, and we really appreciate it.
Thanks.